All right, so now let's talk about Venn diagrams. And the idea here is that a Venn diagram gives us a way to represent, or in other words, visualize sets. So I'm just going to draw a Venn diagram here. So it's usually got a rectangular box, and this rectangular box represents the universal set. Everything inside of it is the universal set. And let's say I'm only looking at two sets, A and B, so we draw circles for those two sets, and in general they might overlap. So here would be a Venn diagram of two sets, and then if I have specific elements in those sets, I represent those with points. So let's say here X is an element of A, Y is an element of B, Z is an element that's in both A and B, so it's going to be in the overlap, and then W is outside of the set A and B, but it's inside of my universal set. And so from this one picture, you can write down all the elements in your sets. I know A, look inside of the A circle, I have the element X and Z. This set B, look inside of the circle corresponding to B, and I have the elements Y and Z. And then I know my universal set has the elements W, so it's every element in the box, so it'll be W, X, Y, and Z. And so now what we're going to do is we're going to take our set operations and represent them with Venn diagrams. So let's start with A union B. What would the Venn diagram for A union B look like? Here's A, here's B. So it's all the elements that are either in A. So all the elements that are either in A or in B. So you're just going to combine them together, and this would be the picture for the union of A and B. The union of A and B. What about intersection? A intersect B. Well, with intersection, it's only what they have in common. So it's only going to be the overlap. So it's just this little part in the middle. Right there. Okay, so that's intersection. Now let's look at the set difference, A minus B. So here's my set A, here's my set B. So it's all the elements in A that are not in B. So all the elements that are in A, but outside of B. So that would just be this portion right here. Inside of A, but outside of the B circle. And how do I do the complement? A bar or AC. So here I only have one set when I'm doing a complement. I have my set A inside of my universal set. So it's everything that's in my universal set but not in A. So I want everything outside of A. Everything outside of A. Okay, so those are all of our set operations now. I do want to mention what the Venn diagram looks like if we have three sets, so A, B, and C. What does my Venn diagram look like if I have three sets? So it'll look like, here's my set A, here's my set B, and here's my set C. And we'll see a little bit more of that later. But let's look at an example. Let's end this particular video with an example of a Venn diagram, a concrete example. So let's say I tell you that U is the universal set. It's from 0, it's all the integers from 0 up to 7. A is going to be the set 1, 3, 4, 5. B will be the set 1, 2, 3, 4. And C will be the set 2, 4, 5, 7. So here I have three sets. Here's A, here's B, here's the circle for C. And I'm going to start with this, I'll go ahead and shade it for the moment. This part right here, this corresponds to all three circles. So it's what A, B, and C all have in common. So what elements do A, B, and C all share? They all contain the number 4. And that's the only number they all have in common. So in here is the number 4. Now let's look at what A and B have in common. A and B have 1, 3, and 4 in common. So in this other part right here, I need to put 1 and 3 there. So I'm going to put 1 and 3 there. And then if I look, what do B and C have in common? B and C have the number 2 and 4 in common. So this space right here, I need to include a 4 there. So let's put a 4 there. A 2. Let's put a 2 there. So B and C share 2 and 4. And finally, what do A and C have in common? They have a 4 and a 5. So between A and C, the part where they overlap, I need a 4 and I need a 5. Now you're going to look at each set individually. The set A has the numbers 1. So let's look at A. It has 1, 3, 4, and 5, which I've already got in my picture there. Inside of the A circle, I already have 1, 3, 4, and 5. Now let's look at B. B has 1, 2, 3, and 4 in it, which I've already got included in my B circle. So the final one is this C here, 2, 4, 5, 7. I'm missing 7, and that's only going to be in the part of C that isn't overlapping with A or B. So that's where that 7 goes. So now let's look at our universal set. What numbers don't I have in my picture so far? I'm missing 0, so 0's outside. I've got 1, 2, 3, 4, 5. I'm also missing 6. And then I've got 7 in my picture. So this is my Venn diagram for this example. And what's nice is it makes it easier to kind of compute things. So let's look at, I want you to compute A intersects C union B intersects C. So if I look at A intersects C, what What do A and C have in common? Look here. What do A and C have in common? They have the elements 4 and 5 in common. What about B intersect C? So I look right here in this kind of region here between B and C. What do they have in common? They have a 2 and a 4. And so now I'm just taking the union of these two sets. So this would be the set 2, 4, 5. So it kind of makes it a little bit easier to do these set operations if I use Venn diagrams.